start? Very good evening. Happy to be here in the Nagpur chapter of Indian Waterworks Association. Thank you, Vikrant, for remembering and calling me and providing this kind of platform. Happy to be along amongst all of you as a core team, wherein I would like to connect in a one-to-one mode, make it an interactive presentation, and in a given time frame of 1 hour, I would like to showcase the technological capabilities of a new, advanced, upcoming area called drones. So let us begin now. As you said, Vikrant, as you said, we should celebrate each day as Earth Day. Would like to connect to my home experiences. Whenever I cut any coffee pouch, my wife always tells me to put the corner which I cut into the main pouch, because that part, small part, is very difficult to disintegrate or we cannot recycle it. On the other hand, my mother, now the gas is being lit by the device, क्या बोलते हैं उसको? Lighter. Yes. But when she lights up the diya before the temple, she uses the used matchstick. वो हम लोग तो हर बार वो नया वाला लगाते हैं. So these are the examples from which we learn, and these are the inheritances from our traditions जो हम लोग अर्थ को बचाने के लिए consciously, subconsciously कर रहे हैं, and we should follow some of the beautiful examples जो हमारे ancestors, guardians हम लोग को सिखाते रहे हैं. Thank you for this philosophical beginning. Let us venture into a new technology domain called as drones. I have put the pictures of international drones and Indian drones onto my beginning slide. The left-hand part is the DJI drone, which are the Chinese leaders into this industry. Very difficult to compete with them because electronic integrations are so meticulously made that Indian companies are finding it very hard to reach near them. But after Modi government's decision, 2021, all import of drones is banned. So now the Indian companies are coming up very fast. Youngsters are putting their brains in developing new drones. The three leaders from international domains are DJI, Winkra, and Sensefly EV, the bottom one. But the top four are the leading Indian drones. First is Aereo, second is IdeaForge, third is Garuda, and fourth is CD Space. So these are the four companies based in Mumbai and Bangalore, which are doing very good into Indian drone industry. Now we normally casually say drones. It's an acronym basically. Drone stands for Dynamic Remotely Operated Navigation Equipment. Many of you must have heard it for the first time. Drone तो बहुत बार सुना है. And people take it very casually because they have seen drones flying in marriages only. And now pre-wedding shoots. वहाँ पे बहुत सारा drones का utilization हमें दिखता है. Then a similar synonymous term which is used for drone is UAV, unmanned aerial vehicle. If I use a UAV or a drone in conjunction, in association with a ground platform which is collecting the DGPS data of the precise locations where the station is kept on a tripod, it is called UAS, unmanned aerial systems. Going to the next slide. This drone technology belongs to a bigger spectrum called as eye in the sky technology. A Marathi or Sanskrit name is Gagana Chakshu. My wife is a Sanskrit teacher. I told her, can you suggest me some name? So she gave me this name, Gagana Chakshu. So eye in the sky technology. Very advanced technologies are coming up. They are like bombarding on us. Very high resolution satellite data up to 30 centimeter. Now the government of India has made it open to use 30 centimeter resolution satellite data to every civilian. Then the microwave remote sensing, the spectroscopy, hyperspectral, interferometry, big data, AI, ML, cloud cloud processing, web portals, deep learning. Now, most of the people are not using softwares and data onto their machines. Here, the sciences team, you are aware that all the data is now residing on cloud, and all the platforms are flooded. The cloud platforms are flooded with data and softwares. We are talking today about a technology called as a drone. So Dr. Abraham Karem is the person who has developed a drone called as a Predator, which is the most advanced drone for the United States of America, which is a military grade drone, and he is known as the father of drone industry. India is not behind any of these countries, any of those countries. So we started integrating the drones, particularly in the military domain from 1990s, and then private firms led by DRDO have come up very fast. In the year 2021, 25th September 21 to be precise, India published its own policy, drone policy, and based on that policy guidelines, all the drone building and drone operating companies or industries are working. These are the different type of drones which are being utilized in scientific engineering domains. Two types are principal. One is a copter, which is a wind-based drone, and another is a fixed-wing drone, which is also called as a bird. Now there is a third type which is coming up, which is taking up vertically, landing vertically, and then converting into bird. So I will just play some of the movies which we have worked. Now this is a demonstration of a fixed wing drone which we have flown on the Fort Raigad for mapping the fort on very high scale of 1:100 meters. 1:100. The topo sheets are on 1:50,000. Now the data is available on 1:100. We'll just see how the drone flies. This is a carbon fiber of body, which is called as a haulage, and then in the belly there is a Sony camera 42 megapixel. This drone, though it is seen very raw, is costing about 15 lakh rupees, including the payload of Sony RGB camera. Now this is fully controlled by a software. In case of an eventuality, the operator is there to bring it back to its original position. Now, once this drone is launched, it will fly for about 40 to 50 minutes, and it will take photographs every 3 or 5 seconds. Those photographs will be 70% overlapping, 70% front lap, 70% side lap, and it will help us to generate a photograph product called as an orthomosaic. Now after flying for 50 minutes, the drone will come down. Now it is the responsibility of the operator, drone pilot, to land it safely, because it is very interesting to see how the drone lands. Now imagine it is a 15 lakh of the apparatus flying with 2.5 lakh of camera and the important data which it has collected. So now see how it is belly landing, crash landing. We were fortunate to find a pitch which the local boys had prepared for their cricket match. We utilized it as a airstrip. So now the person who is controlling is taking the drone down. It has flown for 50 minutes, captured a huge amount of data. So this is really a skillful thing. The little easier thing is flying a copter, which I do, because it is comparatively safe, it is comparatively stable, yeah, and it is taking off and landing vertically. It requires a small space. It does not require any airstrip for landing. The dog is also very much interested to see what technology is being brought onto the Fort Raigad. It is his domain. So this is very easy. The advantage of this drone is it has got a gimbal, and on the gimbal a camera is attached. So the gimbal keeps it stable in XYZ, pitch, roll and yaw is stabilized, and we get a very good quality of picture. Then the upcoming technology is a VTOL, vertical takeoff and landing. I have not flown it, but I have taken a hired from the website of the company which builds it. So this is called as a Vintra VTOL. It takes up as a high copter and then converts into a fixed wing. So this is very convenient. Advantage is it can fly up to 1.5 hours. It can cover 2 square kilometer area in one sortie. Now it has converted into a bird. It will fly, and while landing it will again convert it to vertical position. So this is very advantageous in mining. In small areas we can work on it. Now coming to certain 1 or 2 slides, I will not take you much in the details of the technology. Basically forces are operating when an aircraft is flying. The gravity is pulling it down. The drag of air against its direction of the flight is pulling it back. So we require a powerful engine to get the lift, and we require a powerful engine to add the thrust. Now, how this is achieved? This is achieved through a fundamental concept called as an airfoil or aerofoil. In the aeronautical engineering, this is taught in the first semester. So if I take a cross section of the wing of the airplane, that part is called as the airfoil section. That airfoil section is tapering in the end section and circular in the front section. So the difference in air pressure creates a difference in the pressure. On the top is the low pressure, on the bottom is the high pressure, and this change in the pressure gives us the necessary lift. This is called as the Bernoulli's principle. Will not go much into the details. I will just show the basic parts of the aeroplane which controls the pitch, roll and yaw. What are those? I will discuss in the next slide. So the fuselage is the major part on which all the parts are attached. The body of the aeroplane is called as the fuselage. Then there are ailerons. All of us, when we sit on the wings in the Indigo, we must have seen the wings flap coming up and down. Then there is a rudder in the back which moves in this direction, and then there are the elevators which are moving in this direction. These are the 3 important parts which are controlling the roll, the yaw and the pitch. Whenever any aeroplane or a drone is flying, it will have distortion in these 3 directions: the roll, the pitch and the yaw and the pitch. Now the ailerons which are on the wings controls the roll of the aircraft. Now I will give you one homework. Whenever you are flying, you check whether both the ailerons are working at the same time. If 2 of our colleagues are flying, occupy the window seats and check whether both the ailerons are working, and then you will yourself come to know what the function is. Then the rudder controls the yaw and the elevators controls the pitch of the aircraft. Now 2 integral components of the drones are inertial mapping unit, which are mapping the distortion in the pitch, roll and yaw direction, and the GPS. Without GPS we will not be able to build an ortho or build a digital elevation model. Now that much is enough for copter. Birds will move to the fixed copter. Now this is a copter, quadcopter, hexacopter kind of thing. We have a lot of complicated electronics built into it. Like this is the fuselage, then there is a gimbal. Below the gimbal is a camera, there is a flight direction, there are the propellers, then there are various internal parts like LED indicators, FPV transmitters, cameras, antennas, GPS antenna. Everything is controlled through a software. They call it as a firmware. So a part of the software which controls the hardware. Then these are the details of each and every part which is controlling the drone as a technology, advanced technology tool. Now the foremost parts which are important for flying a copter are the propellers. The propellers are built on BLDC motors, the brushless direct current motors. The speed of the motors and the direction of the movement of the propellers drives the drone. The front left side propeller is moving in clockwise direction, then the front right is moving in anti-clockwise direction, then the third is moving in the clockwise direction. So diagonally they are moving in the same direction, and this is helping the drone to climb up and down. The speed is controlling whether it is going up or going down based on the principle of Bernoulli's, where the difference in pressure is created. Next, now coming to the technology and the background of drone is now over. The flying time of specific drones. The birds, the drones, the copters are very dynamic. The camera can be moved in any direction, but they have a low flight time. Whereas the birds have a larger flight time. So if I want to map larger areas, I will be utilizing the birds, and if it is a small area but I would like to detail out and I would like to have a plan and a perspective view also, I will be preferring a copter over the bird. Next. So these are some of the advantages and disadvantages. The multi-rotors are cheap, they are easy to operate, they are easy for vertical and easy landing. They are suitable for short flights and low coverages, suitable for local mapping and comply with aviation regulations because the weights are also less. Whereas the fixed wings are relatively expensive, they need experienced pilots, horizontal landing and need sufficient spaces in airstrip kind of thing, suitable for large area mapping. Then further classification goes to high altitude long endurance or medium altitude long endurance. How much time they are going to fly. Then what are the applications where the drones are used? Basically for surveying and mapping, when we talk about the engineering and science and technology domain. Infra planning. Now in foreign countries and in Southeast Asian countries, the stages of the development of buildings are being monitored by the drones. They call it BIM. The BIM technology, drone is dominating. Then disaster management, pre-disasters, during disasters and post-disasters. The list is endless. You think of a domain and drone can be utilized. So in 2021, the government of India has published the drone rules. Let us go through the drone rules. It is not very easy to use the drones. The drones are governed stringently by the government of India. Many of the operators do not know. They fly drones like they can take a camera selfie or they can use a camera for marriages and all. It is not the case. So they have categorized the drones into three: aeroplanes, rotorcraft and hybrid. I have already showcased the videos. Then they have classified the drones. Those were the categories. These are the classifications. The classifications are nano, micro, small, medium and large. Now sir, I would like to quote an example. Now when the youngsters order food or order deliveries from Amazon, a person comes and delivers it. In a year or two, a drone will come, give you a hooting sign in front of your location where you have given the location. Now you will not be giving the address, you will be giving location in latitude, longitude, which everybody is acquainted with by acquiring from your phone. The drone will come, and if you have a camera, it will point to the person who is receiving the parcel, a photograph will be snapped, and the parcel will be released. Once the weight is given to you, minus the weight, you will get a message that the order is delivered. So this is the future, because long endurance drones are now coming up and Government of India is working very fast on this kind of technology. Now what are the limitations? The nano drone, which is below 250 grams, can be used by any person in India. You can use it freely, you do not require any permission, you do not require any license to fly it. When it comes to micro, 250 grams to 2 kg, if you are flying for recreational purposes, fly it freely. No questions asked. But if you go above 2 kg to small category, you require a drone license, RPC, remote pilot certification to fly the drone. Same for medium and large categories. These are the examples. So this is a very small drone, 250. These days you might have heard about DJI Mini 3 Pro, Mini 4 Pro, and Droni from Garuda. That's an indigenous drone, named after our legendary Dhoni. He is the brand ambassador of Garuda. So nano drone you can purchase in the range of below 1 lakh rupees and you can fly. Mini 3 Pro, and they are very efficient. In fact, I have done photogrammetry using nano drones, and that has proved us very successful. So these are the 4 drones. Now coming to the rules and regulations, the government of India has defined where I can fly the drones. Below, around the airport, 5 kilometers I cannot fly any drone without permission of air traffic control. Then from red zone 5 km to next 3 km, I can fly with the permission of ATC for up to 60 meters height. And from 5 km to the next kilometers, 4 kilometers, that is called the outer yellow zone, I can fly up to 120 feet or 400 feet or 120 meters. Then for the rest of the place, it is called as a green zone, you can fly freely. This kind of output is available in a website called as an airspace map. You can search airspace map, show your location, and you will get which are the green areas and red areas. Government of India has made it mandatory to get the RPC, remote pilot certification, for flying the drones, and this is example I have acquired it. So these are some of the pre-flights checklist. We have to fill in the flight logbooks, we have to fill in the battery charging, and if any accident happens, then we have to report it to the police in this form. Now coming to the thoda sa science, and then I will shift to the actual case studies. How many of you have seen microwave? How many of you have seen X-ray? How many of you have seen radio waves? You must have seen microwave. You must have seen X-ray. This is a normal question I ask, but this is little deceptive. I've seen an instrument which generates a microwave, which generates an X-ray. I cannot see it. It exists, but I cannot see it. Similarly, there is one more energy which exists called as infrared. So in remote sensing, our sensors are working in 2 or 3 bands of electromagnetic signals. It is called as green, red, infrared, blue, green, red, and infrared. Because vegetation reflects profusely in infrared bands, we use infrared sensor to sense that energy which is reflected by the vegetation. So these are the various spectra, and this is the science behind that the active sun's radiation or electromagnetic energy is striking the various earth surface features, getting reflected, and the reflected energy is getting recorded onto the sensors. So these are the different type of sensors: the RGB cameras, the LiDAR sensors, the thermal sensors, the multispectral cameras, and the 2 different type of important cameras which have come up these days is called as the reddish panchromatic. See, it is capturing blue, green, red, reddish, and near infrared together, and the maximum technological development is happened in a sensor called as Altum. This Altum is scanning blue, green, red, reddish, near infrared, and thermal together. So if I fly a drone with this sensor, I will have everything for analyzing the area on the surface of the earth. The technology which is helping me to generate the various products of the drones is based on a science stream called the photogrammetry. Photogrammetry means measurement from photograph. I can take photographs either with the help of pole, Insta360-degree camera, or balloon, or aeroplanes, or for that say drones. So what the fundamental is, I am snapping photos from different vantage points, and the different vantage points are focusing on the same feature of the earth surface feature. Then these overlapping photographs, the right one, convergent photographs, are being used for building a 3D model of the feature where I am scanning out the area of interest on which I am working. See, I have shown the converging angles, and I have also shown the different directions, the different distances. So the camera is being used from different distances also. So the algorithm which is being utilized into this field of drone technology is called as a structure from motion, virtual structure from motion, VSF. This is what we call. So the basic algorithm which is being utilized is called as the SIFT, the scale invariant feature transform. What it is doing? It is matching the similar objects in different photographs captured from different vantage points and from different distances. Will not go into much details. So more the number of photographs which are overlapping, correct will be my model. So this is the process flow of my VSFM and SIFT algorithm. 4 or 5 important outputs are generated. The important one is ortho-mosaic. The topo sheet is on 1:50,000 scale. The drone technology can develop a map on 1:50 scale. Imagine the details and the information which is coming to the scientific fraternity, and every domain of science and engineering can utilize this orthophoto for analyzing. If I quote the example from Vikrant's domain, if you are mapping a water supply network, and if I have got this kind of output of 1:50 scale and 1:2 centimeter resolution images, I can utilize this image sitting in my AC lab to draw the entire water supply network from source to sink. So this kind of output is valuable. Second is digital elevation model. I can show any area in a 3D model. I will showcase some of the outputs. Two different type of DSMs are generated, digital elevation model DEMS. One is digital surface model, where if I map a fold and it has all trees on non-earth point objects, it is called DSM. And if I remove all earth surface non-earth point objects, it is called the DTM. Then a point cloud and contour of 50 centimeters are generated accurately. So these are some of the outputs. This is done with the help of sciences, then ADCC by MRSAC, wherein the force inherent was mapped. So this is point clouds, these are orthophotos, then this is DSM. If you can visualize, there are certain white dots, and those dots are removed which are non-earth point objects, and 2D and 3D contours are shown. I will showcase some of the better outputs now. So this is a raw photo which is captured by a drone from a height of 120 meters. 120 meters, sir. And this, when you put in a software, will generate me an orthophoto of 1:50. This kind of point cloud is generated. The point cloud can be classified for height, for types of vegetation. So I have categorized it based on the height. So what is the height of different trees are shown by the different color codes. So this is the list of different domains where the drone is being utilized. Now I come to the actual outputs which are generated. This is a case study which we have generated using our drone in a village called Khasarmali, wherein all the soil and water conservation structures are shown here. See, these are all CCTs, continuous contour trenches, wherein the water is infiltrating through the obstructions created on the slopes of the hill. Then these are the farm ponds which we have created. So this kind of outputs can be generated. This is one more example of a village called Umargaon on the Umred Road. So this is an example where we have mapped the entire village, and we have done this for the Honorable Settlement Commission Government of India, which initiated the Swamitva project, wherein these are haphazardly developing areas, Narsala and Umargaon areas, 572, 1900 वाला. तो उसमें they don't have any property cards and they don't have any mechanism to measure also. So we have flown the drone, and based on these orthophotos, then they draw these circles, property ownership details, and give it as a printout to the owners. Then coming to the advanced capabilities, we also generate various outputs like land resources development plans, water resources development plans. I'll just show one of the outputs. So this is one of the output. This is a 3D, sir. You can imagine. Then I can zoom on to this. This is wherever I am clicking, I am getting the latitude, longitude. Then I can say orbit. So if you have this kind of information, I don't have a mouse unfortunately, so I am not able to do it freely. So these are free HTML files, and this kind of files help us to visualize the terrain, where the water is being obstructed, where it is getting infiltrated into the ground. I can quantify the soil and water losses. One more very important video type, drone type, is called as the first person view, FPV. It's a puck-sized drone with a GoPro camera and used with the infrared goggles. I'll just run it and then you will visualize why it is called as an FPV. It is called as an FPV because it is giving me a feel like I am sitting in a helicopter and it is being seen from the eye level. This is an area from Ramte called Skarpuri Baudi. You can imagine like it is as if you are sitting in a helicopter and seeing the terrain. I'll just forward it, save the time. So this is the heritage monument, which is situated on the northern periphery of the Ramtek Hill. Many of us must not have gone to this place. Very beautiful place. I'll forward it further. Now I am climbing, the drone is climbing to show you the Ramtek Hill and the temple complex. Very fantastic view of Ramtek temple complex with the help of a drone, and this is why we call our technology as eye in the sky technology. Now one more added thing is the entire frame, all the frames of these videos are geotagged. Means I can take out a frame and I know the latitude longitude of that area where my drone is flying. Now coming to other areas, like if I want to fly a drone over a mining area which is filled with the water. So this is one more example. Now we have the capabilities of calculating the volumes also. Whatever dumps are being excavated and put over there, the dumps can be measured in cubic meters. Given the uniform depth of the water body, we can calculate the amount of water which is stagnant in the area or the mine. How much time and how much effort will be required to Then coming to one more area where I need to duplicate it somewhere. Let's stop this. Right. So recently in Maharashtra faced a very disastrous situation where a complete landslide disrupted the Irshalwadi village. So we were the first to capture this kind of picture of the disaster area. So the complete chunk of the Irshalwadi fort escarpment came down on the habitation and it led to the loss of many lives. So this kind of post-disaster study helps us to know which lava flows and which constituents of the lava flow are pro for sliding down in case of heavy rains. So this is the village in the bottom you can see, and almost 50-60 villagers were sleeping and the landslide took their lives. Right. So then the most interesting scenario or a case study might be for the Gosipur dam area, where this is the dam site, Gosipur. When the irrigation department used to fill it to the FRL level, full reservoir level, the water used to inundate the villages, the ordnance factory and the Bhandara town. So the irrigation department requested MRSAC to carry out a case study. So what we did, sir, the earlier survey was not up to the mark or they were not satisfied with the survey. So sir, what we did, we went to the dam site and we tried to capture the water level which existed on that day. This is just an example of a 3D model. We call it as a digital twin. Why digital twin? Because the entire dam model is being brought to the scale in a 3D environment onto my desktop. So a decision maker can utilize it for betterment and good decisions. This is a point cloud. So sometimes you will feel like it is blurring. So this is a cloud of points. Every point is having XYZ location attached to it along with the RGB value. See, now the video is indicating the water level. There is a scale in each dam which indicates the water level. So we have created a 3D model and based on this 3D model we measured the AMSL value of the water existing on that day. See, now we are measuring the AMSL. The value is 242.5. Remember this, 242.5. Right? Then what we did, 242.5 was measured. Then we have flown our drone at a distance of around 15 to 20 kilometers. Knowing the fundamental that water will rise horizontally, if I fill the water dam, the area in the periphery will also rise to that height. So what we did, we went to the area where the last water was reaching, and we did an ortho photo. This is an ortho photo and the yellow line is indicating my contour of 242.5 meters. So now this is 242.5 meters, and then we took a larger survey with the help of Sciences. The SOP was formulated and then Sciences was given a larger job. They surveyed 300 kilometers. Imagine doing a survey of 300 kilometers and they found the FRL of 260 something, and that contour now has been acquired so that if they fill it the water to the FRL level, no water ingression will be there into the habitated areas. Then we have also done a case study for Bawal 3D irrigation project, wherein a drone was flown. We requested them to release the water, and then our drone followed along with the water, and a model was calculated, sir. If this much water is released, this much amount of gate is opened, how far the water will go. So a model was established, and this helped them to decide the flow in which the water has to be released so that it reaches the tailings. Right. So these are some of the interesting case studies which MRSAC has taken up. Then coming to my heritage domain. Heritage, we have done a lot of good work. This is the Srinagar fort which we have mapped using a drone. This is Srinagar fort. This is done for the State Archaeology Department, and this is a model called as the DTM, Digital Terrain Model. all the non-outbound objects are brought down onto the ground level. So if I throw a bucket of water, in which direction the water will flow, and this is the technology which has helped us to draw 1 meter contour. Then the conventional architects were facing a lot of difficulty in mapping of a old architectural marvel called as the Kalyan Darwaza. So this was an integrated approach by MRSAC, and we took the help of drone from sciences, and we took help of LiDAR from a company called PMI. And I as a coordinator, we formulated this kind of design. So this is the cloud of point cloud, wherein the back end is my drone and the front end is the LiDAR cloud. And based on this, then we have generated a model which is measurable in 2D and 3D. So this is from the point cloud, we calculated a mesh model. From mesh model, we rendered it with the photorealistic texture, and now you can visualize this is the actual measurable 3D model. We call it digital twin. So now if I measure any brick and ask somebody to go onto the field and measure that particular brick, it will be centimeter level accuracy. So now this has brought a lot of transparency, and the action plans, the implementable action plans are being generated using this technology. Maharashtra is a leader into this kind of technology. After Sinhagad, Chhatrapati Sambhajiraje, who is the chairman of Raigad Development Authority, called us and he entrusted us with mapping the Raigad foot and show the outputs of Raigad also. This is one of the simulation. If a VIP car comes, you can see what kind of cars. Then it goes to a particular monument. This is called as the Pune Darwaza 1. So this is an e-guide kind of thing, sir. So if a person purchases a ticket, he'll get an app into his smartphone and a commentary will be delivered. So now you can walk 200 meters, you will find this monument, what has happened into this location and all. So this is very interesting. Then third is Tanaji Malusari Samadhi area. This is the area where we have brought in some modifications and generated a virtual walkthrough. It is as if we are onto the site, and this is near AR/VR technology. Without using any goggles, we are providing them a 3D view. Certain 3D objects like a flying flag and these trees are introduced, but this is like original point cloud being rendered into various software. Now coming to Raigad, sir. We have mapped the Raigad using two types of drones. One is a bird, one is a copter. This is Raigad Fort Top, shown as a 3D model, Fort Top. Anybody who has seen Raigad will immediately connect, like this is the area where the coronation of Chhatrapati Shivaji happened. Then there are the 6 flat skips of Rani Vasa. Then this is like the place where coronation happened. This is Nazar Khana. And scientifically, if I see, sir, the Hiroji Indulkar architect has utilized the complete water divide areas. Sir, you can visualize the complete water divide are being utilized for construction. So the water of both the sides are draining, and below these are pipes of those EGA which has been put to drain the water from the water divide, and just run this completely. Then these two water bodies, Kushavarta and Gangasagar, and this is the temple and the Samadhi of Chhatrapati Shivaji Maharaj. So we can visualize how much undulations are there, and all these tops are also marked with 1 meter contours. So it is said that Shivaji Maharaj and Sambhaji Maharaj required horse to come to this place. So this is the area of fort is such. Now these are all 3D monuments, sir. So we can map the entire areas. I'll show 1 or 2 case studies and then we will proceed further. This is the maximum which we can achieve using a drone. So this is called as a close range photogrammetry. We have integrated the drone outputs, and we have also integrated the handheld camera. This is called as the Shivgai Devi temple. So the maximum clarity थोड़ा सा distorted using the projector, but this is a model wherein I can measure. See, I am measuring and it is showing me the distance is 1.38 meters. So, if it is a small object, I can take a 3D printout also. 3D printer is there, if the 3D printer is there. So, height is measured, width is measured, and now if there is, this is called as condition mapping, sir. If there is a growth of any tree, if any stone is broken, this kind of stuff is being utilized to prepare the as-built drawings. So, this concludes my experiences and my projects using the drones. The list is endless, but in the given time, I wanted to showcase in very brief so that I am not in a very lengthy discussion. Thank you very much.